The function f from R to R defined as f of x is equal to x power 3 is. So let us check one to one. Let x1 not equals to x2 for x1 comma x2 belongs to R. So which implies that the cube of these real numbers x1 cube is also not equals to x2 cube. It's for any two real numbers, their cubes are not equal. So which implies that f of x1 is not equals to f of x2 since f of x is equal to x power 3. So we had x1 not equals to x2 implies f of x1 not equals to f of x2, which means that no two distinct elements have the same image, and hence we can say f is one-to-one function. And now let us check onto function. Let y is equal to f of x, which is equal to x power 3. So which implies that x is equal to y to the power of 1 by 3. For y belongs to R, y to the power of 1 by 3 is also a real number. So that is x belongs to R. Such that f of x is equal to f of y power 1 by 3 is equal to, since we have f of x is equal to x power 3, so y power 1 by 3 whole power 3, so which is equal to y. It means that for y belongs to R, there exists an x belongs to R such that f of x is equal to y, which means that f is onto function. Means for every image in y, for every image in the codomain, so we can say that there is an image, pre-image we can say. So therefore f is onto function. F is one-to-one and f is onto. So we can say both one-one and onto, which is option D, right? If x is equal to a secant theta and y is equal to b tan theta, then d square y by dx square at theta is equal to pi by 6. Here x and y both are given in parameter theta here. X is equal to a secant theta and y is equal to b tan theta. So let's differentiate with respect to the parameter theta. So that is dx by d theta is equal to, differentiation of secant is secant theta tan theta, and for y is equal to b tan theta, differentiating with respect to the parameter theta. So dy by d theta is equal to b, differentiation of tan is secant square theta. So which implies, so we can write dy by dx is equal to dy by d theta upon dx by d theta, which is equal to b secant square theta upon a secant theta tan theta. So that is b upon a secant theta upon tan theta. So therefore we can write dy by dx is equal to b upon a secant upon tan is nothing but 1 upon cos by sin by cos, that is 1 upon sin, that is cosecant theta we can write. So dy by dx is equal to b upon a cosecant theta, and also for dx by d theta is equal to a secant theta tan theta. So here we can also write d theta by dx is equal to 1 upon a secant theta tan theta, or we can write 1 upon a cos theta into cot theta, or cos theta by sin theta, that is 1 upon a cos square theta by sin theta also we can write. Now we require d square y by dx square, again differentiating with respect to x. Now we are differentiating, not again, differentiating with respect to x. So we'll have d by dx of dy by dx, which is equal to b upon a differentiation d by dx of cosecant theta. So we'll have d square y by dx square is equal to b upon a into cosecant theta is minus cosecant theta cot theta into d theta by dx. So that is d square y by dx square is equal to b upon a into minus cosecant is 1 upon sin theta, cot theta is cos theta by sin theta, into d theta upon dx is nothing but 1 upon a cos square theta upon sin theta. So which is equal to minus b upon a square cos cube theta upon sin cube theta. And since theta is equal to pi by 6, so we have cos theta is equal to cos pi by 6, that is root 3 upon 2, and sin theta is equal to sin pi by 6, that's 1 upon 2. Let us substitute here. Therefore d square y by dx square at theta is equal to pi by 6, which is equal to minus b upon a square cos cube theta is root 3 by 2 whole cube, sin cube theta is 1 by 2 whole cube. So whereby we can write root 3 whole cube is 3 root 3 upon 8 divided by 1 by 8 into minus b by a square. Minus b by a square, so which is equal to 8 cancel, minus b by a square into 3 root 3. So we can give the answer minus 3 root 3 b upon a square. Option A is the answer. Okay. In the given graph, the feasible region for LPP is the shaded region. The objective function z is equal to 2x minus 3y will be minimum at. Since we know that the optimal value, that's minimum or maximum, must occur at a corner point of the feasible region. It's a bounded region. So the corner points are here. Say this is O, A, say this point is B, C, and this is D, and this is E. These are the vertices, we can say, of the feasible region. So the minimum or maximum will be obtained at these vertices. So but among these vertices, so options are given 4 options. Let us check with the 4 options. So option A is, say, this point vertex, and the objective function z is equal to 2x minus 3y. Let us check with the options here. The first option 4 comma 10. Substitute x is equal to 4 and y is equal to 10. So we'll have z is equal to 2 into 4 minus 3 into 10. That is 8 minus 30, which is equal to minus 22. And for the second vertex B, option B, that is 6 comma 8. Z is equal to 2 into 6 minus 3 into 8. So 12 minus 24, which is equal to minus 12. And for the option C, 0 comma 8, objective function z is equal to 2 into 0 minus 3 into 8. That's a 0 minus 24, which is equal to minus 24. And option D, 6 comma 5. So we have z is equal to 2 into 6 minus 3 into 5. That's a 12 minus 15, which is equal to minus 3. So among these 4 options, we can observe that the minimum value will be the minus 24. So minus 24 at point 0 comma 8. So we can go with an option C. At 0 comma 8, the objective function will be minimum. Okay. The derivative of sine inverse of 2x root over 1 minus x square with respect to sine inverse x, where x lies between 1 upon root 2 to 1. So the derivative of, generally, the derivative of y with respect to x is nothing but dy by dx. So here the derivative of sine inverse of 2x times root over 1 minus x square function with respect to the another function sine inverse x. So for our convenience, let us consider u is equal to sine inverse of 2x root over 1 minus x square, and v is equal to sine inverse x. So for v is equal to sine inverse x, which implies that sine v is equal to x. When x is equal to sine v, so we can write sine square v is equal to x square, which implies 1 minus cos square v is equal to x square, or we can write 1 minus x square is equal to cos square v, or we can write cos v is equal to root over 1 minus x square. Okay, sin v is equal to x and cos v is equal to root over 1 minus x square. So our first function u is equal to sin inverse of 2 into x is nothing but sin v and root over 1 minus x square is cos v. So it is in the form of 2 sin theta cos theta. Since sin 2a is equal to 2 sin theta cos theta, so we can write sin 2v. So u is equal to sin inverse of sin 2v is equal to 2v. Now what is required here? The derivative of sin inverse of 2x of root over 1 minus x square, that is u, with respect to sin inverse x is nothing but v. So it is nothing but du by dv. So differentiate u is equal to 2v with respect to 2. So differentiate with respect to v. So we'll have du by dv is equal to, so differentiation of v is with respect to v is 2v, that is 2. So du by dv is equal to 2. So we can give our answer as 2. Option A is the answer. Okay. If A is equal to matrix 1 minus 1 0 2 3 4 0 1 2 and B is equal to matrix 2 2 minus 4 2 minus 4 and 2 minus 1 and 5, 3 by 3 matrices are given, then we have to verify which one is correct. So the options containing inverse. So let us check whether these matrices do they exist inverse or not by finding its determinant. So det A is equal to, so 1 times of 3 2s are 6 minus 4 minus of minus plus 1 times of 2 2s are 4 minus 0 plus 0 times of 2 1s are 2 minus 0. So which is equal to 6 minus 4 2 plus 4 plus 0, which is equal to 6, which is not equals to 0. So we can conclude that A inverse exists. And now let's find the determinant of B. Det B is equal to, so 2 times of 2 5s are 10 minus 1 into minus 4, that is plus 4, and again minus 2 times of minus 20, so minus of minus plus 8, so again minus 4 times of 4 minus 4, which is equal to 10 minus 4 6, 6 2s are 12, and here minus 20 plus 8 is minus 12, minus 12 of minus 2 plus 24, and 4 minus 4 0, it's 36. We can give the answer, which is not equals to 0. So we can say B inverse also exists. Generally given the options, 4 options are given, none of the options says that inverse does not exist. So blindly you can go with multiplication and we can check, but generally we can go in this way, right? It's not so necessary for this problem in this objective case. Now let us find AB. AB is equal to 1 minus 1 0 2 3 4 0 1 2, multiply with 2 2 and minus 4 2 and minus 4 2 minus 1 and 5, so which equals to, so multiplication is row with the column, first row with first column, so 1 into 2 2 minus 1 into minus 4, that's plus 4, 0 into 2 is 0. Next first row with the second column, 1 into 2 is 2, minus 1 into 2 minus 2, 0 into minus 1 0. Next first row with the third column, 1 into minus 4 minus 4, minus 1 into minus 4 plus 4, and 0 into 5 0. Next second row with first column, 2 into 2 4, 3 into minus 4 is minus 12, and again 4 into 2 is plus 8, and second row with the second column, 2 2s are 4 plus 3 2s are 6, and again 4 into minus 1 minus 4. Second row with the third column, 2 into minus 4 is minus 8, 3 into minus 4 is minus 12, and 4 into 5 is plus 20. Now third row with first column, 0 into 2 0, 1 into minus 4 is minus 4, plus 2 into 2 4, and again 0 into 2 0, 1 into 2 it's 2, and again 2 into minus 1, it's minus 2. Now third row with the third column, 0 into minus 4 is 0, and 1 into minus 4 is minus 4, and 2 into 5 is plus 10. So we are getting AB is equal to 2 plus 4, it's a 6, 2 minus 2 0, minus 4 plus 4, it's a 0, it's 8 plus 4, 12 minus 12 0, and 4 plus 6, 10 minus 4, it's again 6. So again 20 minus 12, 8, 8 minus 8 0, and here 0 and 0 here, and 10 minus 4, it's a 6. So we are getting 6 if I take common, 1 0 0 0 1 0 0 0 1, so which is 6 times of 5. So we can say that AB is equal to 6 times of 5. So we can go with an option like a B inverse is equal to 1 upon 6 times of A. So we can take B inverse is equal to 1 upon 6 times of, sorry, A we can write. So we can go with an option D, right? The real function f of x is equal to 2x power 3 minus 3x square minus 36x plus 7 is. This problem is related to strictly increasing or decreasing, and since we know that the function will be increasing when f dash of x is greater than 0, strictly increasing, and when f dash of x is less than 0, strictly decreasing. Strictly increasing and strictly decreasing. Okay, let us check by differentiating the function. F of x is equal to 2x power 3 minus 3x square minus 36x plus 7. So differentiating with respect to x, we have 6x square minus 6x minus 36. So you can take 6 common. So we'll have x square minus x minus 6. So whereby we can write this as f dash of x is equal to 6 times of factorization. We can do it, and we can write, so x minus 3 into x plus 2. So whereby the real line divided by these 2 points minus 2 and 3 into 3 regions, whereby above 3 it is positive. So by using wavy curve method, we can say it's positive, and from minus 2 to 3 it is negative, and again from minus infinity to minus 2 it is positive, and hence we can say that the curve is increasing in the interval minus infinity comma 2, minus infinity comma minus 2, again union 3 to infinity, it is strictly increasing, and again in the interval minus 2 to 3 it is decreasing. So among the options, it is a decreasing in minus 2 to 3, and here increasing in minus infinity to minus 2, but strictly decreasing it is wrong. So we can go with an option B, which is correct. Option B is the answer. Okay. The simplest form of tan inverse of root of 1 plus cos x plus root of 1 minus cos x upon root of 1 plus cos x minus root of 1 minus cos x, where x lies between pi and 3 pi by 2. And since we know that 1 minus cos x or 1 plus cos x is equal to, or 1 plus cos theta is equal to 2 cos square theta by 2, and 1 minus cos theta is equal to 2 sin square theta by 2. So let us use this formula here. So tan inverse of root of 1 plus cos x, we can write root 2 mod of cos theta by 2 plus root of 1 minus cos x, we can write, so this is x here, root 2 mod of cos x by 2 plus root 2 mod of sin x by 2 upon root 2 mod of cos x by 2 minus root 2 mod of sin x by 2. So which is equal to tan inverse root 2, we can take common, and since x lies between pi and 3 pi by 2, x by 2 lies between pi by 2 and 3 pi by 4. Pi by 2 and 3 pi by 4, it is in the second quadrant, In second quadrant cos is negative, so mod of cos x by 2 will be negative. So we can write here minus cos x by 2 plus root 2, and sign is positive, so we can remove the mod and we can write positive here, and divided by, sorry, you can take out root 2 common, divided by again root 2 common. So mod of cos x by 2 will be minus cos x by 2, since cos of x by 2 is negative in the second quadrant, and minus root 2 of sin of x by 2, root 2 taken common, so sign is positive, so we can write sin x by 2. So root 2 gets cancelled, so whereby tan inverse of minus cos x by 2 minus sin x by 2, or if I take minus common, cos x by 2 minus sin x by 2 upon, in the denominator also if I take minus common, so we can write cos x by 2 plus sin x by 2, so minus minus cancel and we can write here, which is equal to tan inverse of cos x by 2 minus sin x by 2, we can write by taking cos x by 2 common, 1 minus tan x by 2 upon cos x by 2, if I take common in the denominator, we can write 1 plus tan x by 2. So cos x by 2 gets cancelled, so which is equal to tan inverse of 1 minus tan theta by 1 plus tan theta is tan pi by 4 minus theta. So we can write tan pi by 4 minus x by 2, which is equal to tan inverse of tan pi by 4 minus x by 2, we can write pi by 4 minus x by 2. So which is our option A. Since let me write the tan pi by 4 minus theta is equal to 1 minus tan theta upon 1 plus tan theta. So using this formula we can write here. So the answer is option A. Okay. Given that A is a non-singular matrix of order 3 such that A square is equal to 2A, then the value of determinant of 2A. The given matrix A is a non-singular, that is det A is not equals to 0, and it's order 3. A square is equal to 2A. Given A square is equal to 2A means these two matrices, square of a matrix and 2 times of a matrix, both are equal. So which implies that the determinants are also equal. So determinant of A square is equal to determinant of 2 times of A. So determinant of A square is det A whole square. So which is equal to determinant of 2A is equal to 2 to the power of order of the matrix A into det A. So here n is equal to 3. Since the determinant of the matrix is order 3, so we can write det of A square is equal to 2 power 3 into det A, that is det A whole square is equal to 8 times of det A, or we can write det A whole square minus 8 times of det A is equal to 0 on factorization. So we can take out det A common, det A minus 8 is equal to 0. So either det A is equal to 0 or determinant of A is equal to 8. Since it's a non-singular matrix, det A not equals to 0. Since determinant of a matrix is non-zero, so which implies that determinant of A can be considered as 8. Therefore, determinant of A square is equal to 2 power 3 into det A. So from here we can write that is 8 times of det A. That is 8 into 8, which is equal to 64. So determinant of A square is 64 and we require determinant of 2A. So determinant of 2A is same as determinant of A square, which is equal to 64. So the third option is the right answer. Okay. The value of B for which the function f of x is equal to x plus cos x plus b is strictly decreasing over the real numbers are f is decreasing or f is strictly decreasing for the values of x in which f dash of x is greater than 0. So let us differentiate here. F dash of x is equal to, decreasing means less than 0 dash x. So let's find f dash of x. 1 minus sin x plus 0. So f dash of x is equal to 1 minus sin x. Since sin x lies between minus 1 to plus 1, so negative sin x also lies between minus 1 to plus 1. And then adding 1 minus 1 less than or equals to 1 minus sin x is less than or equals to 1 plus 1, that is 0 less than or equals to 1 minus sin x is less than or equals to 2. So which indicates that f dash of x is greater than or equals to 0. Since f dash of x is greater than or equals to 0, so whereby we can say it is not strictly decreasing. So which implies that f is not strictly decreasing. And hence we can conclude that there is no value of b exists. So option B is the answer. Let R be the relation in the set N given by R is equal to a comma b such that a is equal to b minus 2 where b greater than 6. So relation is defined on the set natural numbers. R is equal to a comma b such that a is equal to b minus 2 where b is greater than 6. So which of the following ordered pairs belongs to the relation? So it's very clearly that b is greater than 6, so that is second coordinate must be greater than, so first option cannot be. And coming to the second option 3 comma 8, so let us consider b is equal to 8, so which implies a is equal to b minus 2, that is 8 minus 2, which is equal to 6. So ordered pair must be 6 comma 8, but here 3 comma 8, so we cannot, this second option is also wrong. And 6 comma 8 for b is equal to 8, it is correct. And let us check the fourth option also. For b is equal to 7, so a is equal to b minus 2, that is 7 minus 2, which is equal to 5, that is 5 comma 7 must belongs to the relation, but here 8 comma 7 is there, so fourth option is also wrong. So only one option is correct, that is C. Option B is the answer. Option C is the answer. Okay. The point or points at which the function f given by f of x is equal to x upon mod x where x is negative or minus 1 when x is greater than or equals to 0 is continuous. So let us check. Since f of x is equal to x upon mod x for x negative and minus 1 when x is greater than or equals to 0, which indicates that when limit extends to 0 minus means left limit at x is equal to 0. So f of x is equal to, so we can write limit extends to 0, the function can be taken x upon mod x, so which is equal to when x is below 0, so we will apply mod x is equal to minus x, because as per the definition mod x is equal to negative x when x is less than 0 and it is x when x is greater than or equals to 0. So we can write here limit extends to 0 x upon minus x, which is equal to limit extends to 0 minus 1 is equal to minus 1, and also limit extends to 0 plus f of x means when it is above 0, so it is given minus 1, so we can simply write the answer minus 1, and also the functional value f of 0 is equal to minus 1, and here clearly we can say that left hand limit and right hand limit and the functional value all are equal. So for any negative number this function is continuous, and for any positive number x greater than or equals to 0 also the function is continuous, and hence we can say for all real numbers the given function is continuous. Okay, so first option is the answer. If A is equal to matrix 0 to 3 minus 4 and Ka is equal to, where K is a scalar constant, 0, 3, 8, 2b and 24, then the values of K, A and B respectively are given. A is equal to matrix 0 to 3 minus 4, a 2 by 2 matrix, and then Ka is equal to 0, 3a, 2b and 24. If a matrix A is multiplied with a scalar k, so we can write Ka is equal to 0 into k, 0, 2 into k, 2k, and 3 into k it's a 3k, and minus 4 into k it's minus 4k. Now comparing this both k and ka, so we have 3a is equal to 2k and 2b is equal to 3k and 24 is equal to minus 4k, that is minus 4k is equal to 24. So from here we can write k is equal to 24 upon minus 4, which is equal to minus 6. So substitute k is equal to minus 6 in the first. 3a is equal to 2k, so 3a is equal to 2 into minus 6, which is equal to minus 12. So a is equal to minus 12 upon 3, so which is equal to minus 4. So a is equal to minus 4, and substitute k is equal to minus 6 in the second. 2b is equal to 3k, 2b is equal to 3k, so which is equal to 3 into minus 6, which is equal to minus 18, or we can write b is equal to minus 18 upon 2, which is negative 9. So b is equal to minus 9. So k is equal to minus 6, b is equal to minus 9, and a is equal to minus 4. So which is our option? Option B. Okay. A linear programming problem is as follows. Minimize z is equal to 30x plus 50y, subject to the constraints 3x plus 5y is greater than or equals to 15, 2x plus 3y is less than or equals to 18, x is greater than or equals to 0, y greater than or equals to 0. So in the feasible region, the minimum value of z occurs at. Let us draw the diagram. Let's take the coordinate axis. Constants are given. 3x plus 5y is greater than or equals to 15. So whereby the line equation we can write dividing with 15. So we have x upon 5 plus y upon 3 is greater than or equals to 15. The line correspondingly x upon 5 plus y upon 3 is equal to 1. So it's an intercept form. So we can take the point 5 comma 0. So this is the point 5 comma 0 and 0 comma 3 on y axis. So there is a line passing through these 2 points. And since it is given greater than or equals to 15, let's verify with origin. It's 3 into 0, 0. 5 into 0, 0. Is 0 is greater than or equals to 15, which is false. So our region is not containing origin. So the shaded region to be away from the other upper half plane, we can say. And let us consider another line equation. 2x plus 3y is less than or equals to 18. So let us divide with 18. So x upon 9 plus y upon 6 is less than or equals to 1. So correspondingly the equation we can write x upon 9 plus y upon 6 is equal to 1 in the intercept form. So on x-axis 9 comma 0 point. So let me take this point as 9 comma 0 and y-axis 0 comma 6. Let's consider this is 0 comma 6. So let's draw the line joining these 2 points. So this is a line indicating x upon 9 plus y upon 6 is equal to 1, and it is an inequality. 2x plus 3y is less than or equals to 18. Let us check with origin. So 2 into 0, 0 plus 3 into 0, 0. 0 is less than or equals to 18, which indicates that this inequality is containing the origin. So shade the region towards the origin. And since the third constant x greater than or equals to 0, y greater than or equals to 0 means your entire graph is in the first quadrant. In the first quadrant only. And so that we can represent the shaded region, it's a bounded between the vertices. Say this is a 5 comma 0. Let's take this point is b 9 comma 0. Let us consider this point is c 0 comma 6. and the point D 0, 3. See the objective function, the optimal solution is obtained at the corner points only for the bounded region, the feasible region of the vertices. So let us substitute. Since z is equal to 30x plus 50y, let us check. Z is equal to 30 into 5, 150, plus 50 into 0, 0, so which is equal to 150. And next for 9 comma 0, 30 into 9, 270, plus 50 into 0, it's a 0, that is 270. And for third point, C 0 comma 6, 30 into 0, 0, plus 50 into 6, 300. And for fourth point, 0 comma 3, so you are getting 30 into 0, 0, plus 50 into 3, 150. So among these 4 points, we can observe that 150 is the least one, which is obtained at A 5 comma 0 and also at D 0 comma 3. A 5 comma 0 and 0 comma 3, and also we can see that by taking any point. Okay, let us verify with the point here. For x is equal to 1, substitute here. For x is equal to 1, 1 upon 5 plus y upon 3, which is equal to 1, or we can write y upon 3 is equal to 1 minus 1 upon 5, that's a 4 upon 5. So we will be getting y is equal to 12 upon 5. So let us check this in the objective function. Z is equal to 30 into 1 plus 50 into y value is 12 upon 5. So 30 plus 5 10 times 120 plus 30 is 150. Means we can observe that any point on this line segment joining AB, we are getting 150 only. So we can say that there are infinitely many points. Infinitely many points are there where you are getting the minimum value. Okay, so option C is the answer. Please like, share, subscribe and support us. Thank you. The area of a trapezium is defined by function f and given by f of x is equal to 10 plus x root over 100 minus x square. Then the area when it is maximized is, it's a given area function. So the method of solving this problem is, let us find first the value of x for which f dash of x is equal to 0, and then substitute in double differentiation. If it is greater than 0, we can say the area function is minimum, and f double dash of x is less than 0 for the values of x, then we can say it is maximum. So let us differentiate the function. So f dash of x is equal to 10 plus x, differentiation of root x is 1 upon 2 root x, 1 upon 2 root of 100 minus x square, into again by chain rule, differentiation of 100 minus x square is minus 2x, plus again root over 100 minus x square, into differentiation of 10 plus x is 1. So we can simplify minus 2x times of 10 plus x plus 2 times of 100 minus x square upon 2 root over 100 minus x square. And to find the minimum or maximum, we need to take f dash of x is equal to 0 to find the value of x. So which implies, on simplifying, so we can write here minus 20x minus 2x square plus 200 minus 2x square is equal to 0. So which comes minus 4x square, or 4x square plus 20x minus 200 is equal to 0, or we can take 4 common. We can add x square plus 5x minus 50 equals to 0. On factorizing, so we can write here x minus 5 into x plus 10 equals to 0. So either x is equal to 5 or x is equal to minus 10, and clearly for x is equal to minus 10 in the given function, f of minus 10 is equal to 0, which is area function is 0, so it cannot be maximum. So let us consider to be at x is equal to 5, so that So generally actually we need to substitute x is equal to 5 in the double differentiation. We have to do it and you have to perform, since it is an objective case. So easily among the two values 5 and minus 10 cannot be, because if we are getting 0 it cannot be maximum. So we'll assume that it is maximum at x is equal to 5. Let us check here. F of 5 is equal to 10 plus 5 into root over 100 minus 5 square, which is equal to 15 into root 100 minus 25, that is 75. So which is equal to 15 into root 75, we can write 25 3 times, so that is 5 root 3 we can write. 15 5s are 75, 75 root 3. 75 root 3 square centimeters is the answer. So we can say the area maximum is 75 square centimeter, 75 root 3 square centimeter, that is option C. Okay. If A is a square matrix such that A square is equal to A, then I plus A whole cube minus 7A, where I is an identity matrix. Of same order as matrix A, then I plus A whole cube is equal to, we can write I cube plus A cube plus 3A square into A, 3I square into A plus 3I into A square, so which is equal to, I cube is identity matrix for any power is I only, and A power 3 we can write it as A square into A plus 3I square is again I times of matrix A plus 3I times of A square is A. And also we know that identity matrix into any matrix is A only, or I into A, you will get A matrix. So we can write I plus A square is again A plus 3I into A will be A plus again 3 times of I into A is A, so which is equal to I plus A into A square is again A, so again 3A plus 3, that is 6A, so which is equal to I plus 7A, so which implies that I plus A whole cube minus 7A is equal to I. So we can give the answer I plus A whole cube minus 7 times A is I, which is option D. Okay. If tan inverse x is equal to y, then what is the range of y? Means range of tan inverse x. The question is, we know that tan inverse x function is defined for all real values, and the range of tan inverse x is minus pi by 2 to plus pi by 2, which is a principal value branch, we can say. Principal value branch we can consider for tan inverse x is minus pi by 2 to plus pi by 2. So we can consider y must belongs to minus pi by 2 to plus pi by 2. So that is option C, minus pi by 2 to plus pi by 2 y ranges. Okay. Let A is equal to set 1 2 3 and B is equal to set 4 5 6 7, and let F is equal to 1 comma 4, 2 comma 5 and 3 comma 6 be a function from A to B. Based on the given information, F is best defined as whether it is a surjective function, surjective means onto function, and injective function, that's a one-to-one function, or it's a bijective function, means both one-to-one and onto, or it is just only function. So let us check. Here the two sets are given, A and B. The domain of the function is 1 2 3 and codomain is given 4 5 6 7. So in which the mappings are 1 to 4, 2 to 5 and 3 to 6. So first let us check this is a function or not. So every value of A means for every A belongs to A, there exists a unique B belongs to B, such that f of A is equal to B, so that we can say this is a function. And then now we need to verify whether it is a 1-to-1 or onto, or both 1-1 and onto. For 1-1 function, no two distinct elements have the same image, means all three distinct elements have different images, so we can say this is 1-to-1. And coming to onto function, so here for 7 belongs to the set B, so there is no pre-image. There is no pre-image in A, so that we can say that this function is not onto, means not surjective, and hence we can go with an, it is only 1-to-1 function, so the best we can go with function, and it is 1-to-1 function, so we can go with an option B, injective function. Okay, for A is equal to matrix 3 1 minus 1 2, 2 by 2 matrix is given, then 14 times A inverse is given by, we know that A inverse exists only when data is not equals to 0. If A is equal to 2 by 2 matrix ABCD, then determinant of a matrix A is equal to AD minus BC. So determinant of the matrix, given matrix 3 1 minus 1 2, which is equal to 3 into 2 minus 1 into 1, which is equal to 6 plus 1 7, which is not equals to 0. We can say given matrix is non-singular, and hence A inverse exists. And also A inverse is equal to 1 upon det A into adjoint of matrix A. Now adjoint of a matrix A is equal to, interchanging the principal diagonal elements D and A, and other diagonal elements change the sign. So we can write 1 upon 7 into adjoint of the matrix. So we can interchange the diagonal elements. So we can write 2 and 3. And the other diagonal elements, not principal diagonal, other diagonal elements, just change the sign -1 and 1. So this is A inverse, and now 14 times A inverse is equal to 14 upon 7 times of 2 minus 1, 1 and 3, which is equal to 2 times of 2 minus 1, 1 and 3. So multiplying with 2, so 2 2s are 4, and 2 into minus 1 minus 2, 2 into 1 2, and 2 3s are 6. 4 minus 2, 2 and 6 is the matrix. So we can go with an option B. Okay. The point or points on the curve y is equal to x power 3 minus 11x plus 5, at which the tangent is y is equal to x minus 11 is, or r. So there is a curve given at which the tangent is given y is equal to x minus 11. Since we know that the tangent slope is, it is in the form of y is equal to mx plus c, so slope is equal to 1. So we can write slope of line y is equal to x minus 11 is 1, which is the slope of tangent. Which is the slope of tangent to the curve y is equal to x power 3 minus 11x plus 5. Generally slope of tangent is dy by dx. So let's differentiate, that is dy by dx at a point P which is equal to 1. So differentiating with respect to x, so we have 3x square minus 11 which is equal to 1. So 3x square is equal to 11 plus 1 12, so x square is equal to 4. So we can write x is equal to plus or minus 2. So for x is equal to 2, substituting in the curve equation, so you'll have y is equal to 2 cube minus 11 into 2 plus 5, which is equal to 8 minus 22 plus 5, 13 minus 22, which is, 13 minus 22 minus 9. So for x is equal to 2 and we got another point -9, but 2 comma -1 must satisfy the tangent equation. So -9 is equal to -2 -11. So we can say that this point is satisfying, and another point for x is equal to -2. So which implies y is equal to -2 whole cube minus 11 into -2 plus 5, that is y is equal to 8 plus 22, -8 plus 22 plus 5, that comes here -14 plus 5, sorry 14 plus 5 19. So x is equal to -2 and y is equal to 19. Let me check, let us check that whether this point is satisfying this tangent equation or not. So y is equal to, that is 19 is equal to -2 -11. So 19 is equal to -13, which is not satisfying. So -2 comma 19 does not satisfy the tangent equation, and hence we can see only one point, that's a 2 comma -9. So we can go with an option B. Okay, given that a is equal to alpha, beta, gamma and minus alpha, and a square is equal to 3i, where I is an identity matrix of 2 by 2 order. So let us multiply a into a to get a square, alpha, beta, gamma and minus alpha into alpha, beta, gamma and minus alpha. So multiplication of two matrices. So row with column, first row with first column, alpha square plus beta gamma, first row second column, alpha beta minus alpha beta, second row first column, alpha gamma minus alpha gamma, second row second column, alpha gamma beta plus alpha square. So which is equal to a square is equal to alpha square plus beta gamma 0 0 alpha square plus gamma beta. So which is given as 3 times I, that is 3 times identity matrix 1 0 0 1 2 by 2 matrix. So which is equal to 3 0 0 3. Now two matrices are equal when the corresponding elements are equal. So we can take alpha square plus beta gamma is equal to 3, or we can also write this as 3 minus alpha square minus beta gamma is equal to 0. So which is our option 3. Option C is the right answer. Please like, share, subscribe and support us. Thank you.